Hey, so welcome back, and this is another daily LeetCode problem. So today it was called Restore the Array, and it's yet again another dynamic programming problem. So I'll give you a top-down memoization solution for this. So what you're given here is a string and an integer k, where s is equal to like some number, and this number is like in string format. And then you're also given a k, where this is like I think they describe it as the maximum number of possible arrays. And so, or no, you want to return the maximum number of possible arrays, and k should be like the maximum number that you can have there. And so, yeah, right here. And so that all the integers that we're trying to make are in the range between 1 and that letter k. So the only thing to really note here is that, yes, there's a top limit, but also you can't have any integers that are 0. And so what we want to do with this string is we want to be able to split it as many ways as we can, where each number in that array, or that you've split these numbers into, are between this range. And so this is the only really good example I find. So you're given this number here, and this is like the max number that you can reach. And because this is like the largest number, 1317, we know that we're never going to hit this 2000 threshold. And so we could just keep it as it is. That's valid. We could also split it right here in between 1 and 7 to get 131 and 7. And both of those are between that range of 1 to 2000, 13, 17, and so forth, right? And so as you can see, you can have multiple splits here. So you don't just have to kind of divide and conquer and split it. Or you can't just like have one split, like you can have multiple splits to the point where they're each individual like integer here are separated. And so the thing to understand is that in this case, like the output is 0. And that's because like we can't split it at this point between 1 and 0, because the left will be 1, but then the right side will have zeros, and those zeros aren't in this valid range. So once you encounter a 0, you kind of have to end there. So to do this, what we're going to do is, because the result can be really large, we want to store and return the modulus of our answer. And so let's just go ahead and declare that variable here. And so we're going to want to return some response, and we'll create a DP function here, and let's go ahead and define it. And we're just going to have an index that just points to the current integer that we're looking at, and we'll just start with 0. And we're going to cache this because it's a top-down memoization solution. And so from here, there's kind of two base cases. So the first base case is that, okay, what if this integer, which starts at index 0, reaches the end? And in that case, so base case one is that we reach the end of the string. And so in that case, we want to return 1 because that is a valid solution. If you're able to get reach to the very end of the integer, you've processed them all. They were all between this range, and then so that is another way, another possible array that can be used to restore it. Okay, and so let's go ahead and say, okay, if I is greater than or equal to, or we can have equal to the length of the array. Let's go ahead and define that. I guess the length of the string, I mean. Let's go ahead and return 1 because that's a valid path. The second base case is, okay, the thing that we know is definitely invalid is when we reach a 0. And so we could either reach the end, and the only thing that can come before that is if we reach a 0. We know that once we see that, okay, you know, this value here is 0, then we can just go ahead and return 0 because that's not a valid path or a valid array. So if s at I, if this particular integer is equal to 0, then let's return 0 and not consider it valid. So we find an invalid path. Awesome. And so from here we have like two different cases. So case one, or no, really just I guess one case, kind of. And so we're going to iterate through all of the remaining options that we have for j in this particular range. And so at the end of this, we're going to want to return some result. And let's just take the mod of it here. And so we're going to want to iterate through all the integers between I, which is our current index, and the end of the string, because we want to consider all possible splits here between I starting at 0 and everything else. And this is a common pattern, especially for like graphs and backtracking, where if you're trying to do something like all possible splits or all possible paths, like you want to iterate through that entire range. And so from here, let's just define our result, which is initially 0. And we're going to need another variable called like total. And total is going to be like the current sum of all the values that we have at like the current index, right? So this one would be 131, or say if we're at this point, it would be 17. And the reason we want this is for the second invalid path where our number is greater than k, which is like the largest number that we can have. And so that's like the other invalid path that we have to consider. So if our total is greater than k, which is our maximum integer, then we want to just break here and return the current summing result, because we can't just keep adding integers to this cell if it's greater than our total. So let's just stop there and just return what we have. And so to get that total, we want to add the current cell at I. And so this will get the current number, or at j, sorry, that we're considering. Because this is a string, we just want to convert it into an integer. And then because we're adding numbers, and these numbers have weights, like, you know, this is 1, but this becomes 10, you have to times the previous values by 10 just to, you know, give them the proper weight that they should have. And so let's just multiply the current total by 10 and then add the newest number that we're looking at. And so if that number is greater than k, then let's stop here. Otherwise, we want to keep adding to our result by performing a recursive call at j plus 1. And so that we can say, okay, we just considered splitting it here. Let's consider now splitting it at the next step beyond this point. Okay, and let's go ahead and run that. Oh, index out of range. Let's see here. I to n, pass I, j plus 1. Oh, let's say for j in, but I have to say range here. Oops. Try submitting that again. And that's the solution. So I think it was fairly intuitive. I think the main catch here is just building that intuition from understanding or doing problems related to this, where you can have not just splitting it, you know, in half here, but having like a split at every single possible range where they become all separate cells here. And so just by doing this and understanding the recursive calls between this for loop, but then at every single split here, recursively calling it and just drawing out the layers really helps with this. I also found like the catch here of once you see 0, stop there and don't continue processing really clever, so that you can translate like this bunch of zeros, immediately just stop there once you see that it's 0, rather than just parsing all these out individually and then finally recognizing here. But yeah, so that's today's problem, and I hope it helped. Good luck with the rest of your algorithms. Thanks for watching.